Alright, getting away from control flow for a little while, we're going to talk about collections this week. All the types that are available in Python, how they relate to different languages, and we're going to look at some basic operations using some of these different collection types. So, getting straight into it, what a collection is a single object in a programming language that can hold numerous pieces of data. So you might have a list containing a bunch of integers. You might have a set containing floats or strings. So these are, you can think of them as the very basic form of a data structure, which is something you're going to get into in more advanced programming classes. Some more advanced programming structures would be things like hash tables, which we're actually going to see here. But also trees, graphs, linked lists, and other things of that nature. We are focusing on the very, very basic one that I have just heard referred to as collections in many, many circles. So, again, a collection is a single object in a programming language that is capable of holding numerous items. So, in Python, the exact content does not matter. Like, it can be, here's an int, here's a float, here's 2 strings, here's another 3 ints. Type is very flexible, and that does create some resource overhead issues that are worth discussing, but are beyond the scope of this class. But some properties of sets, lists, tuples, dictionaries that we're going to talk about here. Your collections may or may not be ordered. In other words, their contents are in a fixed sequence. It could be first in type of sequence where the first thing you put in is at the head of the list or the set or whatever. Or it could be in some other order. Indexed. This means that we can reference them using the array index notation, the slice, the element notation, whatever word you have assigned to it in your own head. There's a lot of different terms to go by. Basically, it's the bracket notation that we did with strings before. They can be mutable. In other words, their values can be modified. Scalable, meaning you can add new values to them after they've been created. Some of them may or may not be able to hold repeated values. And lastly, they may or may not be sorted. And collection sorting or sorting any type of structure is a very complex topic that goes beyond the scope of this course. It goes way beyond the scope of this course. It's something you probably won't be talking about until your 3rd or 4th programming class, because there's a lot to discuss with sorting. It's one of the most common ways that we learn more advanced algorithmic thinking. But for now, we are not concerned with it at all. We are going to focus on these other properties of collections. So we see here, collections can be nested inside each other. You can have what we call n-dimensional lists, where you have a list that contains more lists, that each contain more lists. You can do this indefinitely. These have a purpose. Usually you don't see more than a 3-dimensional, though. But multi-dimensional collections do have a purpose. Just know that they can incur significant resource usage. They can be slow to read and write to. They can take up a ton of space in a hurry. And so we have to be careful how and when we use these, but we're going to talk about exactly what they look like later. So here's a little table that will help you to visualize what Python's different collection types can do. So the first one we're going to look at is the set. This is distinct from the mathematical set, but the principles are still there. So looking at a set, it is not ordered, indexed, or mutable. So we can't easily reference a single value in a set. We can use the membership operator, though. It also does not allow repeats. Everything in a set must be unique. And lastly, it is scalable. We can add new stuff to a set. And we're going to see that in later slides. Tuples, these are not scalable or mutable. However, they can hold repeats. They are ordered, and we can use bracket notation, the subscript, to reference them. Again, we'll see that. Lists, these are the most common ones you're going to use. These are capable of all of these features. They are ordered, indexed, mutable, scalable, and they allow repeats. This is the main one that I want you to focus on in this class, that and dictionaries. Dictionaries do not allow repeats, kind of. So we'll talk about what I mean by that. We'll also talk about what we mean when we say that they are sort of indexed. We will see as we go along. We've got a lot of things to cover here. So let's get straight into sets. So this is some code that shows sets being used, and here on the right is the code being run. So firstly, we create an example set that holds some car brands: Ford, Chevy, BMW, and Toyota. And the first thing we want to do is print the set. You can see that the way we write a set is the contents are contained in curly brackets, just like a mathematical set. Like I said, the principle is there. So we print it, we see open curly brace, Ford, Chevy, Toyota, BMW. Hold on, that's not the same order. That's where the point made in the previous slide comes in. They're not ordered. So when you print them, you're not necessarily going to get the same order. So we can look at how long any collection is using the len function. So we have here a print call. This list, I don't know why I said list, but it should be set. This set is len example set elements long, and we see the print here. It says it is 4 elements long. Now we have some conditional statements here. We have a test value, Chevy, and we're going to say if test value in example set, in other words, if Chevy is a member element of example set, then we do test value 1 found. Otherwise, we do example set dot add test value, and this is going to include the value in the set, even though it is not there. So this will evaluate to true. So what we'll get, as you can see, is Chevy found. Now we do another test value. This one has GMC. And we're going to do the same thing. If we find it, then we say GMC found. Otherwise, we say that it's added, and then we print the new set. So if you look here, we have GMC found, and then BMW, Ford, Toyota, GMC, Chevy. Completely different order from last time. And we'll do it again here. So BMW, Toyota, Ford, Chevy. It's 4 elements long. We found Chevy. We didn't find GMC, so we added it, and now it says Toyota, GMC, BMW, Ford, Chevy. And every time we print this, it's a different order. This is lending to the fact that it is unordered. Do I understand the intricacies behind it and why it looks like this? Why it's always different, why it's unordered? Not really, because I don't use sets all that often. So if you're curious, I encourage you to look that up on your own time. But I really don't use sets very often, so I don't concern myself with why they are unordered like this. So now we have tuples. I use these even less. So we have a tuple that is created using parentheses. So your name of your tuple equals, open parentheses, the stuff you want to put in it, comma separated, close parentheses. So here we have Microsoft, Amazon, Meta, and Google. So the first thing we're going to do is we're going to loop through this. And we're going to say for element in example tuple. So for each of these, we're going to print their length. So Microsoft is 9 letters long. Amazon is 6. Meta is 4. Google is 6. Now we have 2 test values, and we're going to use these the same way we did before. However, we can't just add them if they're not found, so we just have to say not found. So test value 1 in example set, test value 1 being Amazon, then we say it's found. Amazon is indeed found. Now we have our test value 2. Is Apple in our tuple? No, it is not. So Apple not found. Again, this is not an item that I use very often in Python. So I don't want you to focus too much on it. What I do want you to focus on, however, is lists. And we're going to spend a few slides talking about lists and what they look like. So, the first thing to note, we've created an example list, and its contents are in square brackets. So, we have an example list that contains some names: Scarlett, Alex, Amber, Keith, Brian, David, and Michael. Now, we have some comments here explaining what we're doing. The first thing is we're printing the first element. That's print example list sub 0. And of course, that's going to print Scarlett. Now we're going to print the last element. This is another way we can do this, and in some programming languages, this is how you have to do it. We get the length of the list, and then we minus 1 to get the final index. In Python, you can always just use minus 1. So here we do last element equals len example list minus 1, and then we print example list sub last element. Again, you can just skip the whole last element thing and do minus 1 for this. Then we want to print every other element. So we do print example list 0 to last element in increments of 2. This is not going to work quite as well as we would hope. If we had an even number of elements, then we would end up losing that last one that we are supposed to print. So we see Scarlett, Amber, Brian. Actually, it should print Michael here, but it doesn't because we are excluding last element. What we should have done was just left that space between the colons blank. So, and the last thing we're going to do, print the length of each element. And boy, don't this look exactly the same. So, for element in example list, print len element. And then, of course, we get 7, 4, 5, 5, 5, 5, 7. So that is the very basics of lists. Next thing I want to talk about is list composition. You're going to see more examples of all this stuff later, but here we have the same example list with 7 names: Scarlett, Alex, Amber, Keith, Brian, David, Michael. Now, what we're going to do is we're going to create another list from this list. And this list is only going to have names that contain the letter E. And this is what it looks like when we do list composition. This is a quick way, an efficient way to create a new list. So, in square brackets, we say element, for element in list, and then some condition. So, doesn't this look similar to what we did back in the discussion of sets in mathematics? You can kind of read this as names with e's equals the set name such that name is in example list and name contains an e. This syntax is something I'm not exactly expecting you to use in any of your assignments, but you may find use for it, and it is a very powerful tool, a very useful tool, but to a new programmer, it may not be the most readable. So if you wish to use this and you find a valid use for it, go right ahead. But otherwise, don't worry too much about it. I want you to be aware of how it works, but it's not something that has a great deal of focus in our assignments. So then, of course, we print our names with e's, and that gives us Scarlett, Alex, Amber, Keith, and Michael. We've lost Brian and David. Now, let's do another name. Another list. We'll call it short names. So here is our list composition. You can see we can have things on multiple lines here. So I have short names equals name for name in example list on the first line, and then we have our conditions on the following line. If len name is less than or equal to 5. And that's going to create then the list of names containing Alex, Amber, Keith, Brian, and David. And then we're going to use the enumeration that we saw in the for loop discussion for I, comma, name in enumerate short names. And we say print number and then string I, and we add a colon, and then we add the name. So that's what this is going to look like here. Number 0 is Alex, number 1 is Amber, number 2 is Keith, number 3 is Brian, number 4 is David. So that's some more advanced things with lists. Now let's look at two-dimensional lists. You will be needing this at some point in your assignments, so it's important that you understand how this works. So we have a list that contains 3 lists. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. The way that you reference a two-dimensional list is with 2 instances of your subscript, your bracket notation. The first one is going to reference the row. So list sub 0 is going to start by looking in the list containing 1, 2, 3, 4, 5, and then we're going to look for the second element, sub 1. So if we have the list of lists as shown above, lists sub 0, sub 1 is going to give us 2, because that is first row, second column. Conversely, we have print lists sub 1, sub 0. That is going to give us the second row, first column, or 6. And lastly, we look here, we have print lists sub 2, sub 3. So that's going to be third row, fourth column, which is 14. Now, what do we do if we want to loop through the contents of a two-dimensional list, if we want to get each and every item? Well, we need to use we need to use a nested for loop that looks something like this. So the first thing we do is we loop through each list in lists, and then inside that loop, we loop through each number in list. You can see how the naming forms a neat little logic to it. So we have the list called lists, and then inside that, we want to look at each list. And then inside each list that we're looping through, we also want to loop through each number. It's going to take some practice. We're going to do a fair bit of examples here. And then, of course, we print number, and we end with a space. And then what's going on here is we print each number separated by a space, and then after we are done with each list, we then go down by one line. So you can see how that's printed here. 1, 2, 3, 4, 5 on the first row, 6, 7, 8, 9, 10 on the second, 11, 12, 13, 14, 15 on the third. We'll have to do a lot of practice, and we're going to take our time. But this should give you a few ways that we mess with lists in Python. Now we're going to switch gears and talk about dictionaries. Dictionaries, there's a bit more to these. There's a little bit more. Instead of being a straight-up list of things, this is a list of key-value pairs. What that means is you have a unique key. It could be a string, it could be a number, it could be a float, it could be whatever, but they have to be unique. And each of those is assigned some containing value. So, in other languages, you might see these called hash maps or hash tables. Their syntax is, you have the dictionary name equals, in curly braces, you have key 1 colon value 1. You comma separate each of these, so it's key 1 colon value 1 comma. Key 2 colon value 2 comma. All the way until you get to key in colon value in closing brace. So, values, when we're talking about a dictionary, are accessed using a sort of subscript, but instead you want to reference the first key. So if your keys are strings, then it would look something like dictionary sub open quotes, the string that you're referencing, closing quotes, closing bracket. To iterate over a dictionary, we have a few options. You can say for key in dictionary, and that's going to loop over all the keys. You can say for value in dictionary.values, and the values function is going to give you a collection just containing the values within the dictionary. Or we can say for key comma value in dictionary.items. Items is going to return information for both key and value. So let's see one in action here. We've got a simple dictionary that contains a list of usernames, or keys as usernames, and their values are email addresses. We've got a bunch of prints going on over here on the right. So let's take this one line at a time. So we have users equals the dictionary containing sjmaddox, bwillis1 at jsu.edu, jsevan is, we see here, jevans32 at stu.jsu.edu, mburnham, mburnham at jsu.edu, and tw clark7 at stu.jsu.edu. Apart from mine, all of these are just random ones made up. So, if we want to add a new user, it's really simple. It is incredibly simple. So we have user sub kballen equals kallen11 at jsu.edu. So we have, all we do is we're trying to reference it, and if it's not there, if that key is not there, then it'll add it. If it is there, then it'll just change its value. Now, if we want to print the value of an element, let's say we want to print mine, print users sub sjmatrix. To print all the keys, we do for key in users, print key. To print all values, we do for value in users.values, print value. Or if we want to print the whole dang dictionary, we do for key comma value in users.items, print key colon space value. And you can see over here on the right how all of these are going to look. Dictionaries are a very powerful tool. I encourage you to play around with all of what you've seen here. This has been a lengthier lecture than normal, I feel. So, again, practice with all of these. We're going to do some practice in subsequent lectures. But for now, I want you to get a grasp of the basics on your own. So, when we come back, we're going to do lists. We're going to do some basic ones. Then we're going to do some composition, then two-dimensional lists. Then we're going to do some work with dictionaries. This is going to be a pretty long set of lectures compared to the others. Maybe not so much in number of parts, but in actual length of time. So stick around for that.